In this video, I'll be helping you with the ALEKS problem type called solving a system of linear equations of the form y equals mx plus b. And in this example, we're given these two equations, both in y equals mx plus b form. And the advantage of this form for solving a system of equations is that since they are both already solved for y, we can go straight into substitution. Because if y is equal to, in this example, 9x plus 13, I can replace the y in the equation above with 9x plus 13. So to show what that looks like, if I replace this y with 9x plus 13, then on the left-hand side, we have that 9x plus 13 equals, and then in the top equation, I have the right-hand side as 2x plus 48, so 2x plus 48. Doing that substitution, I now have a single equation with only a single variable. I can solve this for x. I would first want to get the x's on one side of the equation, and I can move this 2x over to the left by subtracting 2x from both sides. This would give me on the left-hand side 7x plus 13 equals, I've canceled the two x's, so I now have just 48 on the right. Continuing to solve for x, I can isolate that term by subtracting 13 from both sides. This gives me just the 7x on the left and 48 minus 13, 35 on the right. Lastly, to solve for x, I need to undo multiplying by 7 by dividing by 7 on both sides. Canceling the 7's, I now have the x by itself. 35 divided by 7 is 5. So we have solved for x. X is equal to 5. And that takes care of the variable x. But to solve for the variable y, I can go back to either of these equations and substitute that x back in. It doesn't matter which one we choose. I'll just use the top one that says y equals 2 times x, but we now know that x is 5. So substituting in 5 for x plus 48. Simplifying here, 2 times 5 is 10 plus 48. Y is 58. That gives us the second variable. So we've solved for both variables by substituting one of the y equations in for the y in the other equation, and then solving from there.